alliterative appeal. Alliterative. The phrase duplication divergence has a certain alliterative appeal, which probably accounts for its commonness in the evolutionary literature, even though it is merely a special case of replication and divergence. Pardon me. Although it is merely a special case of replication and diversification, in any event, whether we are thinking about processes where something becomes duplicated or more generally multiplied up in number, the end result is that a creature comes to possess more than a single copy of a part. Let's focus for a while on arthropod segments. These structures begin to be formed during development as transverse stripes of tissue running across the embryo in which particular genes are switched on and so are making their protein products. These proteins can be thought of as sending signals to the overall developmental process, such as make a segment boundary here. If something causes more such stripes to be formed than usual in a certain individual, that individual will, later in its development, have more segments than usual. The something might be a mutation in another gene that controls the positioning of the stripes of the one we started with, or it might instead be an environmental influence such as increased temperature that somehow deflects development from its normal course. Whether the segment numbers of the first ever whatever the segment numbers of the first ever arthropod, it is certain that both increases and decreases in numbers have occurred in its various descendant lineages. The same may be said of the number of vertebrae and associated ribs and muscles in vertebrate animals such as ourselves, and in plants. The number of leaves has undergone changes in upward and downward directions, though this example is messier because there is lots of variation even among different individuals of the same species. Humans, all, or almost all, have the same number of vertebrae. But maple trees certainly do not all have the same number of leaves. What segmented animals and trees have in common is a modular design. Each of the many modules is in a given individual, whether segments, leaves, or whatever, has a common developmental program, not so much in the strict sense of being identical, but rather in the loose sense of being similar to a variable degree. Now, if you find yourself at any point in evolutionary time as a modular organism that has lots of more or less identical modules all doing the same thing, and you do not need as many as you have got in order to do that thing adequately, you have redundancy, which can be exploited by evolution. New types of parts can be created by diversifying some of the existing modules to do new things while still leaving enough of the old ones to do whatever it was they did in the first place. This process of diversification requires no special magic. In fact, we already looked at how it might work at the cellular level in the last chapter. Starting with a single cell type, a mutation that causes cells to develop differently in response to light will lead to the appearance of skin cells and internal cells. And although segments and leaves are much more complex than cells, indeed each consists of thousands of cells, the principle of diversification of overrepresented modules is entirely similar at these different levels of organization. It's time for some specific examples. We'll look at the following in sequence: the front end of vertebrates and the front end of arthropods, the back end of arthropods, the flowers of higher plants, and the brain of an octopus. Like all the major groups of animals, vertebrates started off in the sea. They thus had to breathe water, not air, and so had gills rather than lungs, just as do the fish of the day. But unlike most of today's fish, the earliest vertebrates had no jaws with which to capture their prey. Instead, they had a primitive kind of mouth that took the form of a roundish hole, and they sucked up detritus through this opening, digested whatever was digestible, and ejected what was not in their feces. They were a kind of living vacuum cleaner. Today, a few species still have this design, but it has largely been replaced by the more